Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about chapter 2, that is your higher mathematics. Especially we will talk with the partial fraction and especially one CQ. This CQ is very important for your examination, and partial fraction plays a very vital role in any times, in any places, especially the competitive exams. Let's have a look at our today's class. So dear students, according to our lesson plan, our discussion topic is 2. And here our first discussion topic is actually the partial fraction. And we'll discuss 11 and the question number 3, where here is given x square minus 9x minus 6 divided by x minus 2 into x plus 3. How we can solve these types of problem? That's our first criteria to solve. Okay, since here we have been seen that the denominator of this part, all of them have actually the degree 1. That's why we can assume this part like this way, that our solution should be like this, that our assumption first. Let us assume that our this expression is equivalent into a divided by the first part, that is x, plus b divided by second part, that is x plus x minus 2 actually, and here the last part for that is we can write c divided by x plus 3. So when we have completed our assumption, we will give this as our equation number 1. This is our equation number 1. Now when we have assumed our this partial fraction, then we will go for the multiplication, by which we can multiply this equation number 1 by the denominator of given thing. So here is given this part, and here the denominator is x minus 2 and x plus 3. So we'll multiply this by both sides. Then what we'll get actually? So we should have to write right now that multiplying both sides by x into x minus 2 into x plus 3 in 1, what we get actually? By multiplying we get x square minus 9x minus 6, because this part has been cutting down by that part, because if we multiply this into this, then this will be cancelled, is equivalent into a into, since x is here and if we multiply up to this part, so x is gone, then this 2 will be remaining there, x minus 2 into x plus 3. Here b, that means x minus 2 will not be there, so it should be x into x plus 3, and here x plus 3 will be cancelled, so that x into x minus 2 will be in there. So we can write this as our equation number 2. Okay, maybe one question arised in mind, how we can multiplying it and why it has come like this way. Sometimes you can't understand, that's why I'm going for the another line for your understanding. Actually we was trying to actually multiply this part with the denominator, that means what? X square minus 9x minus 6 divided by x into x minus 2 into x plus 3. If we multiply this part into our that part, then what will be happen on the time? On the time, actually dear students, we will saw that these 3 will be cancelled, so only this part will be remaining there. Now if with this, that is a by x, if we multiply this part, that is x minus 2, x plus 3, then x cancel, then what was remaining in there? A into x minus 2 into x plus 3. Can you understand? Exactly. So if we similarly multiply this into that part, then x minus 2 will be cancel and this 2 will be remaining there. So by this way actually we have found this equation number 2. Clear? Okay. Now we'll go for our next step. Actually this step is the putting the value of x in here. So how many values we'll put for the value for x? That is very simple. Here what part was multiplying or what was our denominator? We'll just think about the denominator first. X plus 3 all are equal to 0. That means we'll get x equals 0, x minus 2 equals 0, x plus 3 equals 0, and that means x equal 2, x equal minus 3. So actually we'll put the value for x is 0, 2 and minus 3 respectively. If we putting the value of this in our equation number 2, then we'll get a, b, c respectively. Okay, let's have a look our calculative part. Putting the value, putting x is equals to 0 in 2, what we can find? Putting the value for x equals 0 in 2, we'll get 0 square means 0 minus 6 equal to a into minus 2 plus 3 plus b into 0 into 3 plus c into 0 into minus 2. Then if we calculate all of that, then we will get the value for a is minus 6 equal, it is minus 6 into a. That means the value for a is 6 divided by 6, so it is 1. So we have found the value for a is 1. That's our first value we have been found. Now we'll putting the value for x is minus 2, so that was 2, and then minus 3. Then we'll get actually b and c respectively. Okay, now we'll go for the second part. Putting x equal 2 in 2, then what we'll get? We'll get actually 2 square, that is 4, 9 into 2, 18 minus 6 is equal to a into 2 minus 2, that is 0, and 2 plus 3, 5. Then b into 2 plus 3, that is 5. And here c into 2 minus 2, 0. So here we have found very clearly that minus 20 is equal to 0, 0, so it will be the only one, that is 10b. So the value for b is minus 20 divided by 10. So if we cutting down all of that, then we'll get the value for b is minus 2. So what we have been found? The value is b for minus 2. Okay, so what we are supposed to do, we had to put the value for x was 3. One was 0, another was 2, and another was minus 3. We have already putting the value for x is 0, then 2. Now what we have to do? Exactly, that is minus 3. Okay, now if we put the value for x equal minus 2, actually minus 3, then what actually we have been found? So minus 3 square, that definitely 9. So 3 into 9, 27 minus 6 is equals to, here is minus 3 into 3, so it should be 0, minus 3 3, so it will be 0, and here we will get actually c into minus 3 into minus 2 minus 3, that is minus 5, and here we have seen that it is 30, and here we get 315c. So we'll get the value for c is actually 30 divided by 15, that is nothing but the 2. So what we have been found in here, dear students, we get the value for c is 2. So here we have found another value c, which is 2. So we have already find our three unknown part, that is a, b and c. If we putting the value of a, b, c in equation number 1, then we get our resultant answer. Okay, just putting the value for a, b, c right now. So putting the value of a, b, c, then what we can get? Putting the value of a, b, c in 1, we get what? We get finally x square minus 9x minus 6 divided by x into x minus 2 into x plus 3, which was equivalent to a divided by the value for actually a was what? The value for a was, we have found, that is 1. So 1 divided by x, then plus the value for b was minus 2, so it should be 2 divided by x minus 2, and value for c was exactly 2, so it should be plus 2 divided by x plus 3. So this is our required, what the question says, express as the partial fraction. So that was our actually required partial fraction. So that's our required answer. So my dear students, I think you all can understand what's the procedure to solve these types of partial fraction and how we can solve this very clearly. Okay, now we'll discuss a CQ. Okay, let's have a look our next question right now. So here, dear students, we are discussing about CQ number 13 from your textbook, and this theme of the CQ is talking about P of ABC is equals to A plus B plus C into AB plus BC plus CA, where actually we need to find the question number 1. Here the question number 1 says, express with proper region whether P of ABC cyclic or symmetric. Cyclic or symmetric. So how we can solve these types of problem? First of all, we are trying to focus on the cyclic part. What's the definition to be a function is cyclic? Can anyone tell me? Exactly. To be cyclic, actually A, B, C. If this works cyclically, that means A will be changed or replaced by B, B will be replaced by C, and if C is replaced by A, that means if we change all of this expression, and after changing the expression, if the function remains same, then we can say that is actually the cyclic expression. So what actually we are talking about? Here we are talking about that there was given A, B and C, and here actually A will be replaced by B, B will be replaced by C, and C will be replaced by A. So if we put the value BCA at the place of ABC respectively, and if we get the same function back, then we can say that function is nothing but the cyclic function. Okay, let's have a look how we can solve the question number 1. So here, solution. So here what is given? Here is given P of A, B, C, that is what? A plus B plus C into AB plus BC plus CA. So if we put here, if we put here, the place of A is B, at the place of B if we put C, and at the place of C if we put A, then the function will be turned into BCA, and that will be what? That will be actually B plus C plus A. A will be replaced by B, B will be replaced by C, B will be replaced by C, C will be replaced by A, and here C will be replaced by A and A will be replaced by B. So we have actually found this. Now we are trying to match this with this. Can we match it? Let's have a look. Here we can write A plus B plus C very easily. So we can write it, and which is actually equal to up to this part. And here AB plus BC plus C, if we write like this order, then definitely we got this equal to this. So this is nothing but the P of A, B, C. Since we have here seen that P of BCA is equals to P of ABC, then we can say this expression or the function is nothing but the cyclic expression. So this is a cyclic expression. Hence P of A, B, C is a cyclic expression. Okay, now we'll talk with our second part, that is whether it is symmetric or not. So how we can prove that that is symmetric or not, that is our second part to understand. So at the case of symmetric expression, actually there was three things, that was A, B, C. So if among these three, if interchange only two of them, that is, say for example A is replaced with B and B is replaced with A, if it looks like that, and after replacing both by each other, if the expression remains same, then we can say that expression is nothing but the symmetric expression. So how we can go for that? Here is given what? Here is given P of A, B, C equal A plus B plus C, AB plus BC plus CA. Here you can write something, that putting the value of A or at A equal B and B equal A, then we can write it, or you may write here directly. Anything can be okay. Just you have give a side note, then it will be okay. So here, what about P of BAC? B, A and C. We'll now look upon this part. So I think you have already understand what we should have to write right now. Here A will be replaced by B, B will be replaced by A, but C will be remain unchanged. Similarly, here A will be replaced by B, B will be replaced by A, B will be replaced by A will be replaced by B, but C was remain unchanged. So what we can write right now? We can write here A plus B plus C very easily, and now here we have found that BA, AC, CB. So can we write BA as AB? Is it possible to write? Exactly, because here was multiplying, A and B are in multiply way. So BA can be written as AB, then BC can be written as CB, and CA can be written as AC. So AB plus BC plus CA, and which is exactly is equals to P of A, B, C. Here you can write a comment that since P of BAC is equals to P of ABC, so this expression is nothing but the symmetric expression. This is a symmetric expression. Okay, so I think, dear students, you all can understand how we can solve question number 1 by this way. Okay, now our next math is question number 2. So dear students, here our question number 2 says if Q equals 0, prove that A equal B equals C or AB plus BC plus C equal 0. To solve these types of math, we need to see is there any value of Q is given or not. Yes, definitely Q is given there. But to solve these types of math, before I wanted to go for a formula. Write down this formula: A cube plus B cube plus C cube minus 3ABC. What's the formula of it? You have already known, that is, it can be written as A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Write down it that A cube plus B cube plus C cube can be written as like this way. Okay, and there is another formula of it. What that is? That is half of A plus B plus C into A minus B whole square plus B minus C whole square plus C minus A whole square. So this has actually two formulas. One is this and another is this, and this math can be solved by using both of these formula actually. Okay, but now we are trying to focus on actually by solving this way, so that we can get this very easily. So write down these two formula, because these two are very, very important. So now we are going for the solution. So what is given here? Here is given Q is equals to A to the power minus 3 plus B to the power minus 3 plus C to the power minus 3 minus 3 to the power A inverse 1, B inverse 1, C inverse 1. So this can be written as 1 by A cube plus 1 by B cube plus 1 by C cube minus 3 into 1 by A, 1 by B, 1 by C. Isn't it? I think you all can understand this can be written like this way. And if we write this like this way, 1 by A, if we think that 1 by A is considered by A, then we can write it like this: A cube plus B cube plus C cube minus 3 into A into B into C. What is the formula of that? What I was just right to understand you, that is, we can write this formula by half into A plus B plus C, A plus B plus C into A minus V whole square, B minus C whole square, C minus A exactly whole square. So we have used that formula what I was remembered to you. Now here we have observed that actually that Q is equals to 0. So according to question, what you can write? According to question, Q equals 0, that means this part is equals to 0. So what you can write actually, half into 1 by A, 1 by B, 1 by C into 1 by A minus 1 by B whole square, 1 by B minus 1 by C whole square, 1 by C minus 1 by A whole square is equals to 0. If this equals to 0, then what we can write? We can write that either this part equals 0 or that part equals 0. So here half of 1 by a plus 1 by b plus 1 by c equals 0, or these all are equal to 0. 1 by a minus 1 by b whole square plus 1 by b plus 1 by c whole square plus 1 by c minus, actually minus not plus, a whole square equal to 0. And here actually half, if it sensed its side, then 0 into 2 will be 0. So if we going for the LCM in here, a b c, then we get bc plus ca plus ab equal to 0, and abc into 0, that will be 0. Then we will get ab plus bc plus ca equal to 0, and that is exactly our this proof. So it has been proved already. Now we are thinking about the second part, what we have to prove, where there is given a equal b equal c. How we can prove that? When some parts are remaining by add way and all are the squares, so this part will be 0 on that time if all are remain or all are individually 0. If these are not individually 0, then this expression cannot be 0, isn't it? So we can say here 1 by a minus 1 b whole square equals 0, or 1 by b minus 1 by c whole square equals 0, or our third part 1 by c minus 1 by a whole square equal to 0. So if we calculate here, then we will get actually ab, that is b minus a equals 0, and ab will be going there, so here actually a equal to b, a equal to b. And then similarly here what we got from here, actually square will be going there, so it should be bc, that is c minus b equal to 0, that means b equal to c. And here 1 by c minus 1 by a equal to 0, that means c equal a. So if a equal b, b equal c and c equal a, then we can say obviously a equal b equal c. That means we have our proof. So what we can write for our last line? For that last line I wanted to erase something, so we should write like this: since a equal b or b equals c or c equal a, that means we can go for a comment a equal b equal c, and we have already a formula that is that. So a equal b equals c, or we have already found from here, that is ab plus bc plus ca is equals to 0, which is our. So here we can say that this equals 0, or ab plus bc plus ca equal to 0. These are required proved. Clear? I think, dear students, we can understand this math very clearly. And now we will go for our last math, that is question number 3. So dear students, that's our last math for our today's lecture. Here there is given p of abc equal abc. So we will start from our given part. So solution, what is given here? Here is given p of abc is equals to abc. So now putting the value of p of abc, and what is given here? Here is given actually abc is equals to nothing but the a plus b plus c into ab plus bc plus CA, which is equals to ABC. Now multiplying by this into this, what we get? We can get actually A, that is A square B plus ABC plus CA square. Okay, now B will be multiplying all of it, then AB square plus B squared C plus ABC. Now C, that is ABC, then CB square, that is BC square plus C square A is equals to ABC. Here we have to match one by one so that we got all of that from the one common part. If we take actually A square B and AB square, then what we get? If we write A square B plus AB square, then we can take common AB, then we'll get A plus B. So we'll try to take that 2 by 2 pair so that we get all of times A plus B as common part. So if here A, B, C, then which part if we take, then we get ABC. Since here if we take that the BC related something, that is like this, B squared C actually, B squared C with this, then if we take BC as common, then it will be A plus B. Now CA square, what we need to find actually? A plus B. So here must have to be A and C should be remain. So if we actually remain actually ABC, then we'll get CA. If it is common, then it should be A plus B. So actually we have taken already these two. Now ABC and ABC will be cancelled, and from that two what we can write? BC square plus C square A, that is if we take C square as common, then A plus B. And here ABC and ABC are cancelled because ABC minus ABC, that will be 0. So here we have found all of the part ABC is remain as common part. So ABC will be remain here first A plus B, and there AB plus BC plus CA plus C square is equals to 0. Now again we have to think like this way so that we can common, or we can take common something. So if from AB and VC, if we take here as B, then we get AC. Similarly if we take C, then we'll get AC. So again we can write AB, I mean A plus B, and if here we take B as common, then we get A plus C, and C from there, then we'll get A plus C. So what we get from there? A plus B, B plus C, C plus A is equals to 0. So dear students, we have found our conclusion from this part is A plus B into B plus C into C plus A equals 0. What we have been actually always told or talk with, or we are actually used to talk, that is A plus B, B plus C and C plus A, isn't it? Okay, you may write it equal to 0. Now A plus B will be individually 0, B plus C will be individually 0, C plus individually 0. That means A is equals to minus B, B is equals to minus C, C is equals to minus A. Then putting the value of in left side and right side, then we will get our resultant proof. Okay, so I will erase the part, then we'll go for our final conclusion. So now here we have found that A plus B, B plus C and C plus A. That means actually A plus B equals 0, or B plus C equals 0, or C plus A equals 0. That means actually A equal minus B, B equal minus C, C equal minus A. So actually if we put any of it in here, I mean left side, right side, and if we get our solution, then we can say that will be our solved. So here if a equal minus b, then what will be our left side in here? So at the case of left side, there was given 1 by a plus b plus c whole to the power 7. So we'll just put here at the place of a, we'll put minus b plus b plus c whole to the power 7. Just putting the value of a in here. Then we get 1 by c to the power 7. So what about the right side? 1 by a power 7, b power 7, c power 7. Then we get 1 by a was minus b, so minus b to the power 7, or you can like this way also, plus 1 by b power 7 plus 1 by c power 7, that is minus 1 by b power 7 plus 1 by b power 7 plus 1 by c power 7. Then this is neglected, 1 by c to the power 7. So here we have found that left side is equals to right side for a equal minus b. Similarly, we can see that for b equal minus c if we put, then we get the same thing. For c equal minus a if we use, then we will get our solution again. Since we have found for solution for left side and right side are equal, that's why we can say that is our hence showed. Hence we have showed our resultant answer. So dear students, that's all for our today's lecture. Hopefully this lecture is very beneficial for you. If you have any confusion, don't hesitate to contact with us. We'll be very happy if we get your responses. Thank you. Stay home, remain safe.